The second method to come up with the differential gain of the amplifier is to use the small signal analysis. So basically we find the AC gain of the differential amplifier. There are three approaches which lead to the same answer. The first approach, which we will cover next, is called by superposition. So basically what we do is we apply Vn1 and kill Vn2, solve for the output voltages Vx and Vy due to Vn1, then kill Vn1 and apply Vn2 and solve for Vx and Vy due to Vn2. The first thing we're going to do is we're going to kill Vn2, so we short it to ground, so the circuit will look like this. And now, as you see here, we have applied V1 and we have killed V2, and we are interested in the AC signal analysis. So basically what that means is the current source becomes open circuit, and now we can analyze the circuit using AC signals. So one of the things we will be looking at is we would like to see what's the equivalent resistance seen at the source of M1. Basically we will look outside the source of M1, which is basically looking into the source of M2. And we know from previous lectures that when we look into the source of a transistor, we see 1 over Gm. The source resistance looking into M2, which is looking out of M1, is Rs, and that will equal to 1 over Gm2. Then the equivalent circuit becomes easier. What we have now is Vn connected to the transistor, and then at the drain we have Rd1, and here is Vx. And then at the source of M1, its equivalent circuit is 1 over Gm2. Now we can solve for the voltage Vx due to V1. We can solve for Vx very easily because the circuit is common source amplifier with a degenerated resistor in the source. We know the output voltage of the circuit, which is Vx due to V1, so that basically minus the top resistance over the bottom resistance times the input voltage, so that is minus Rd1 over 1 over Gm1 plus 1 over Gm2 times Vn1. So that is easy to solve for. Now the question is, how would we find Vy due to V1? Vy due to V1 is a little bit tricky. The way we're going to do it, we will Thevenize M1 into one voltage source and one equivalent resistance, and then we can solve for the circuit. So the way the circuit will look like is we will have a Thevenin voltage source connected to our Thevenin, and then we will have the source of M2, and then we have M2 connected to Rd2 connected to the power supply. And keep in mind that we are doing AC circuit analysis. Basically, to find the portion of Vy that is caused by Vn1, we Thevenize M1, and then M2 becomes common gate amplifier. When you solve for our Thevenin becomes 1 over Gm, and that makes sense because when you look back into the source of M1, you see 1 over Gm1, and we also know that the gain from the gate to the source is unity if the output resistance is open circuit. Right? So these are by inspection. Remember, Thevenin circuit says disconnect the load, so you disconnect M2, and then we're going to look at the output resistance. The output resistance into the source is basically 1 over Gm, and the gain from the gate to the source is unity if the output resistance is 0, if the output resistance is infinity, and lambda is 0. So basically our Thevenin is 1 over GM1 and the Thevenin voltage is VN1. Now we can solve for Vy very easily. So Vy is the top resistance over the bottom resistance times the input voltage. So we can say that Vy1 is equal to Rd2 over 1 over Gm1 plus 1 over Gm2 times Vn. So we can say now Vy minus Vx, which is the differential output voltage due to Vn1, is equal to 2 times Rd over 1 over Gm1 plus 1 over Gm2 times Vn1. And we know that Gm1 equals to Gm2 and Rd1 equals to Rd2, then we can say that Vy minus Vx due to Vn1 is basically Gm times Rd times Vn. And by similar analysis, we can say that Vy minus Vx due to Vn2 is basically minus Gm Rd times Vn2. And by adding the two equations together, we can say now Vy minus Vx due to Vn plus Vy minus Vx due to V2 is basically Gm times Rd times Vn minus Gm times Rd times Vn1 minus Gm times Rd times Vn2. And now by factoring out the Gm times Rd term and dividing by the differential input, we say that the differential gain, which is Vy minus Vx over Vn1 minus Vn2, will equal to Gm times Rd. And this is the differential gain for the differential amplifier.